Dear colleagues, thank you very much for your interest in this presentation. I'm going to present some results of the ongoing remote sensing activities taking place in the Beaufort Sea coast and in Western Arctic Canada in the framework of the project Nunatariuk, funded by the European Commission, and also a collaboration with the Geological Survey of Canada, especially through the Climate Change Preparedness in the North program in the communities of Tuktoyaktuk. This project aims at studying the changes and the complex interactions taking place between the Arctic Ocean and the permafrost coasts, including the linkages between what is happening on the terrestrial environments and on the ocean. The Arctic Ocean has been changing steadily in the last decades. Atmospheric warming associated to the Arctic amplification has been generating reduced sea ice extent, especially during the summer, which directly implies a larger fetch, which means a larger area of ocean winds generating increased wave activity, increased storminess, which associated to warmer seas linked with the highest amount of energy that is absorbed by the ocean, also includes or generates higher erosion along the coasts. Furthermore, there is sea level rise affecting several of the areas along the coast, and in the inland areas, the atmospheric warming also affects the permafrost, further increasing its degradation. In fact, many of the Arctic is composed of ice-rich permafrost coasts. Many areas have bluffs, like the area we are studying in the Beaufort Sea area, where we have frozen material directly exposed to the ocean action, which induces very fast retreat rates. These high retreat rates have important implications for the global carbon cycle, and this is one of the goals of the project, to better assess the carbon budget associated to coastal erosion, but also implications in what concerns to infrastructure, the impacts on local communities, and also changes on the coastal and nearshore environment. We are picking up in fact, we are using different approaches of remote sensing, essentially multi-platform remote sensing in a synergistic way, and I'm going to showcase some of these approaches we are using in order to better understand what is going on along the Arctic coast. One of the approaches we are using is resurveying coastal sites along the Yukon coast using UAVs. These are areas which are retreating at a very fast pace, and our main goal is to develop high quality baseline surveys with an accuracy of about 10 centimeters, as you can see here in this image, where we can see very well the helicopter shape reconstructed in the digital surface model. And this allows us to estimate very accurately the coastal retreat, and also the volumetric changes and the influx of sediment from the land to the seawater. Furthermore, we are using high resolution SAR imagery, essentially Terra SAR-X, and also the PASS satellite from ISDASAT for intra-seasonal monitoring of coastal retreat at several key sites. And in a more classical approach, we are using the CNES Pleiades satellite acquisitions at alpha meter resolution in a special task in cooperation with the Polar Space Task Group of the WMO, with acquisitions being made from the Yukon to the East Tuktoyaktuk Peninsula and further eastwards in the Darnley Bay area. This allows us to understand and to characterize at a very high resolution the coastal erosion rates. For instance, these are rates in the Mackenzie Delta area, and you can see in red rates of more than 20 meters per year in the last 18 years. As a final remarks, I would like just to emphasize that the synergistic use of different remote sensing platforms, both linking field observations with remote sensing imagery, is really important for improving our understanding of the Arctic Ocean. And thank you very much for your attention. The time is running up, so I would ask you, if you are interested, to stop the film and have a look at the final remarks along this slide. Thanks a lot.